This will be lesson 2 for our unit 15 look at sequence and series, and in this lesson we'll be digging into the arithmetic sequences. And if you recall from the last lesson, an arithmetic sequence is one in which we're adding between each successive term and it had a common difference. A geometric, we were multiplying to get the next term. To get the next term in an arithmetic, we're adding. So, and that can be technically a positive or negative number that we're adding. So you could look at it as we're either adding or subtracting. So the formula rule for the nth term, so that means we can find any term in the arithmetic sequence. We could find the 27th term, we could find the 33rd term, etc. using this pattern right here. So that is given as a sub n equals the a sub 1, that would be the first term, plus the quantity, or plus the common difference times the quantity n minus 1. So a sub 1 again is the first term, and d is that common difference. We could find that common difference by subtracting one term by the one before it, and that's what they're showing you here. So it says, example 1, find d, the common difference, and the general formula rule for the following sequence. So if you look at this pattern here, we need a couple of things. We need a sub 1, and then we need to pick a term within the sequence. We need at least the first term and one other term, and we need to know which one it is. So the easiest thing to do here is to identify a sub 1. So a sub 1 is equal to 4, and then just pick a term. So I'm going to go ahead and pick this one in the middle. So this was term 1, term 2, term 3. So a sub 3 then, the third term, is negative 10. The common difference I can find by taking one term, so we'll take this one, negative 3, and subtracting it by the one before it. So negative 3 minus 4 equals negative 7. So let's do it this way. The common difference value is equal to negative 7. So now we know everything that we need to identify the rule. So common difference is negative 7. That's part of the answer. Now we need the rule. So it would be a sub n is equal to the first term, 4, that's this value, plus negative 7 times n minus 1. Now we can simplify this a little bit and distribute that negative 7 in, and we would get negative 7n plus 7. Combine 4 and 7, like terms there. And finally our rule is a sub n equals negative 7n plus 11. So there is our rule, a sub n, and here's our common difference. Now for the second part of example 1, it says, what is the index n for the term negative 164? So we'll be using our rule from before. So the index value means what term number is it? Is it the third term, the 12th term, the 5th term, whatever. The index value is what that means. So we want to know what term number, which is called what is the index of negative 164. So we plug that into our formula we established before, the rule for this sequence, and we get negative 164 equals negative 7n plus 11. So we're solving for n, which is the index value, which means the term number for negative 164. So we subtract 11, we get negative 175 equals negative 7n, divide negative 7, and that's 7 there. So negative 175 divided by negative 7 is 25, so n is equal to 25. So negative 164 has an index value of 25, meaning it's the 25th term in our arithmetic sequence. Okay, example 2 here. Given the arithmetic sequence in which a sub 5 is 20 and a sub 19 is 104, find a sub 16. So we're given a sub 5 equals 20. We're asked to find one in the middle, which is somewhere in between. I shouldn't say the middle, it's not necessarily right in the middle. So we're asked to find a sub 16, and we're given a sub 19 is 104. So we're going to be using our formula rule here for the arithmetic sequence, but unfortunately we're going to have to make some adjustments here to make it work. So we need this a sub 1 value. We need the first term. Well, the first term that we're given here is a sub 5, so we need to make an adjustment to its index value. so that we can plug it into this formula. So a sub 5 is going to become a sub 1, and we need that so that we can plug it into the formula right here. So we had to subtract 4 from the index value. If we subtract 4 from this index value, we have to subtract 4 from that one and from that one. So we're making the adjustment here. So a sub 16, subtract 4 from that would be a sub 12. A sub 19, subtract 4 from that, that would be a sub 15 is equal to 104. So now we need the common difference. We're going to plug in these values to find that into the formula. So the new 15th term, the adjusted 15th term, is equal to 104, so that's going right here. And that's equal to the first term, 20, plus the common difference we don't know, times n minus 1. Well, we're using the adjusted 15th index value there, so 15 minus 1. So 104 equals 20 plus d times 14. So we subtract 20. Here we get 84 equals 14d. Divide by 14, running out of room here. And we get that the d value is equal to 6 if you do that work. So we have a common difference of 6. Alright, so now we can find this term. So our a sub 16 value, which actually is adjusted to be a sub 12, is going to be equal to the first term, 20, plus the common difference value, 6, times the quantity n minus 1. Well, remember, we had to adjust our index to be 12, so it would be 12 minus 1, or 11. So next step is 20 plus 6 times 11. So that equals 20 plus 66, so that equals 86. So our answer is 86. A sub 16 is equal to 86. A lot of students get confused because we have to make this adjustment so that the formula works out. So don't let that confuse you. The 16th term of the given sequence is equal to 86. Not the 12th term, even though we made that adjustment. The answer that we found is the 16th term from the original given arithmetic sequence. Okay, example 3. Find the value of the term of index 25. So in other words, the 25th term. So a sub 25 is what we want to find from the following arithmetic sequence. Alright, so if we look here, we can see that we're subtracting 4 each time. So our d value right away, d equals negative 4. We can see that because we have successive terms here that we can use. So 3 minus 7 is one way we could do it. 3 minus 7 is negative 4. So we take this term, subtract it by the one before it. So the d value is negative 4, and let's paste in real quick that formula so that we can work through that. So we have this value now. We know that this is a sub 25, and we know that this value right here is equal to 11. So we have everything we need to find the 25th term. So a sub 25, no adjustment needed here, equals a sub 1, 11. This is a sub 1, the first term in the sequence, plus our common difference value, negative 4, times n minus 1. So that would be 25 minus 1 because we're finding the 25th value. So let's simplify a little bit. 11, and this would be minus 4 times 24. So that would equal 11 minus 96. So that would equal, if you do 11 minus 96, you'll get negative 85. So the 25th term is equal to negative 85. Okay, next section. The terms between two given terms of an arithmetic sequence are called the arithmetic means of the two given terms. So you can, if there are 3 terms between, then you can have 3 arithmetic means between them. So just be careful. This can be a little confusing. It doesn't just mean if you're working with, say, a sub 17 and a sub 19, and a sub 18 is the one between them. It doesn't necessarily mean that, and we'll see that later in this example. So for example, quickly here, you could have a sub 17 and a sub 20, and if you were asked to find the arithmetic means between them, then that would be 18, 19 would be the ones you would find, a sub 18, a sub 19. So it's not just the one directly between, like halfway in the middle, in other words. So just be careful with that. All right, so example 4. Actually, let's go through the shortcut. If there's only one arithmetic mean between the two given terms, it's simply the average. Okay, so that was the first example we talked about. What is the single arithmetic mean between a sub 4 is 19 and a sub 6 is 27? So, given this, a sub 4 and 19, has to find the one between them. A sub 5, a sub 6 we're given as 27. So we just take the average of the two. So it would be 19 plus 27, all divided by 2. 19 plus 27 is 46. Divide that by 2, and we get 23. So a sub 5 equals 23. Okay, example 5 here. What are the three arithmetic means between the two terms a sub 105? So we're given a sub 105 equals 22, and a sub 109. So we're given a sub 109 equals 217. So between those would be a sub 106, a sub 107, and a sub 108. Those are the ones we need to find. Well, we're going to use this formula to find those values, and we're going to find the common difference first because that's what we don't know. So we have to make the adjustment. We need an a sub 1. This is the first one we're given, so we have to replace it. Therefore, we have to adjust the index value accordingly. So this becomes a sub 1 now, and that's equal to 22. So this then would become the new a sub 2, a sub 3, a sub 4, and then this is the new a sub 5 equals 217. Alright, so now we plug in that information to the formula. So you take the last term you're given, 217. It's going in right here in the formula. And that's equal to the first term you're given, 22, plus the common difference we want to find, times the index value minus 1. So that would be 5 minus 1, or 4 in this case. So we get 217 equals 22 plus 5 minus 1 is 4 times d, so 4d. Subtract 22 here, and 217 minus 22 gives us 195. So 195 equals 4d. Divide by 4 here. Unfortunately, that's going to give us a decimal value, so d equals, that would be 48.75. So we know the common difference, so now all we have to do to find these other terms is add 48.75 each time. So 48.75 plus 22 is 70.75, so this one is 70.75. 70.75 plus this common difference is 119.5. And then 48.75 plus that, again, that's the common difference we're adding each time, 168.25. And if we added 48.75 to that, we would get 217. So that is it for example 5, and that is it for this video.